Okay, so yeah, this is the first component, version control with Git. I'm going to be going through a lot of things and doing a couple demos. So while I'm going through any of these, feel free to ask a question either through chat or just feel free to turn on your mic and interrupt me. But what we're going to be going today is roughly what is Git and talk about a few of the elements there. Then I'm going to walk you through Git setup. And my goal for Git setup is for all of you to have working Git. When I say that is you're able to clone things from the alias repo, and you're able to use all the Git tools. Then we're going to have a simple demo and an advanced demo. If there are any issues, you can jump into a breakout room and someone else can go to the breakout room to help you. If not, we can also do it here. Okay, so yeah, let's go right into it. What is Git? Well, Git is essentially a tool to track changes. So I don't know before if any of you have done this, where like either you're working on an assignment or you have a bunch of code, and what you do is you copy the entire folder and you rename it like final or final. And every single time you make a change, you keep renaming it and adding stuff to it. So basically, Git is a tool to avoid you from doing this and keeping all these changes organized and making it easy for you to know what is the difference between final for real, final version 2, and it's also a very good tool for collaboration. So if you think of your code as a timeline, as time progresses, you will make edits to it and it's going to change. So when you can have an initial final version, you realize, hey, I have a couple bugs, I'm going to fix it. Then you create a new version of it. And every single time you're making a new iteration on it. So you can think of these iterations as a snapshot of your code in time. And if you clump them up together and add a few labels, this is what we consider a commit. And if you use a Git tool, this will organize it all for you. So when I say a Git commit or version, it's essentially a snapshot of the code at a moment in time where it says, hey, this person wrote it and this is their email to contact them, a message just to be able to describe the changes in them. And a note I will say is try your best to have descriptive commit messages. Most of the time, people just write like, oh, update 1. But instead, what you should really use this is as a tool for anyone to look at the specific commit. And just by reading the commit message, they'll be able to tell what changed. And then the parent commit. Because you can essentially think of this as a linked list. There's a node, and then it'll point to the next one and the next one. And you have your initial pointer, and then you have your final one. Yeah, so roughly, this is the kind of information that a commit would have. And when we say a snapshot is essentially just what the code was the moment you made the commit, and it's the code that you checked in. So this is the code that you made Git be aware of and start checking for. So the next part is, what does it look like whenever you make a new commit? So if 2 commits track changes, right, you're able to use a command called git diff on 2 different checksums, which is what we use to identify a commit. And then you'll be able to tell the differences. So for example, if I run a git diff between final and final, I can see what the changes are. For example, in the file alia.py, I added a constant and I just returned the constant instead of having it, right? This is removing a code smell. While in Aspecto, all I did is I changed the definition. Yeah, and just a quick little note on Git hashes. So these are what we call SHAs, or the Git hash, and they're the unique identifier for each commit. Instead of using a human readable message, we have these hashes because they will always be consistent. And there's 2 versions of them. there's the long version, the full-length SHA, and then there's the short one. You can use either one to reference commits, but sometimes in the UI you will see, you'll look at a branch and it'll say, oh, this is on commit, whatever it is, and you'll see a very short one. But whenever you copy it, you'll get the very long one. But you can use either or to reference things when using Git. Okay, any questions so far? How are we doing? I'm just doing a quick little check-in. Am I going too fast? Doing all right? Okay, cool. Yeah, so expanding a bit more on how it's a tool to collaborate. It essentially works as, whenever you're working on a project, usually, you're working on your own laptop and you're combining things with your coworkers online. So what we consider the upstream, or whatever's stored on a server, that's what we call the remote repository. It's remote because you have to go through the internet most of the time. And the term repository is just essentially a code base or a database that just tracks everything in Git. It stores all the changes, and whenever we have a local repository, it's local because whenever you make changes, you don't have to go through the internet to do it. So that's what we call a local repository. So whenever you clone something, you grab it from the remote repository, so from upstream, and you're cloning it what we call downstream, or local. So when you clone something or you're grabbing code from, we call this a pull because you're pulling from the cloud. And whenever and you can think of push as publishing your changes to the cloud, so you're pushing everything to the server. And cloning is just you're copying the remote repository locally, but also what you're doing is you're creating a new local repository. Okay, and yeah. Okay, so expanding more on thinking of your code as a timeline. So you can think of it as you have a main timeline, right? This is the main branch, and you will start making changes to your code. So we have the initial version. You make some changes. You make a second commit, and this will have a different snapshot of your code, and you'll keep going. You can think of this as this is known as a branch. And all it is a set of pointers going to a direction. So yeah, a branch is just a labeled pointer to a commit that will then have other commits associated to it. And what you can do is you can create a branch, which is you will create a new distinct pointer that you could reference that will lead to another version of it. So if we're in the original 1, 2, 3, we can add more commits to it. So we could do 1, 2, 3, 4. And then we can grab this feature branch and add commits on the branch and on the feature branch, and they won't be reflected on the main branch. Is that clear, or did I confuse anyone? Okay. And this means that you can have sometimes alternate branches of your code. And your feature branch will sometimes be missing a lot of commits that were checked into the main one. So when I say checked in, I mean added to the main branch. So sometimes you can get discrepancies, or sometimes you want to add, you want all your changes from your feature branch to be added to the main branch. Say you worked on some drivers and it's, you tested them, they work, and now it's time to add them to the main one. So what you're going to do is you're going to do a merge, which is essentially you're grabbing all these commits and you're adding them to whatever the head, to whatever the main branch is at. Yeah, and this is just a merge commit, and you're combining both histories onto them. And traditionally, how these merges work, unless there are any conflicts, is the new timeline will look like 1, 2, 3, 4, 5, 6, A, B, C. So you'll always, merge onto the top of the range. Oh, okay, yeah, there it is. And alternatively, you can also do a rebase, which you'll replay them on top. And this one is, rebase is very useful for, just updating your branches, not just merging. So usually what we call a merge is, you're joining two branches together. But when you do a rebase, you can do this on a branch. Well, you can merge branches that are not the main one. But a rebase, all you're doing is you're grabbing the commits and putting them on top. So if you think of it as, each commit has a bunch of changes, you're just going to put those changes right after whatever the main branch is at right now. Yeah, and it'll make a very, very clear history. Okay, and yeah, just a little note on conflicts caused by merging. So whenever you merge code, there's odds that you're going to be changing the same files. Say, commit C is changing the same file as commit 5. And sometimes you're even going to change things like the same line, right? And whenever you do that, how a commit really works is it's going to grab, the main branch and the feature branch that you're merging from, and it's going to compare the changes. And if it notices that, commit 5 changed the same thing as commit C, then it's going to say, hey, we have a merge conflict. There's 2 alternate versions. So for example, styleguide.md is one of the files that could have been touched by both branches. And usually when you look at the file, so what Git is going to do is it's going to grab all the files that have an issue or a merge conflict, and it's going to add these labels to them. So when you open them up in an editor, you're going to see, oh, I see this label called head, and I see this label called, branch or whatever the name of the branch is. And reality, what it's doing is it's telling you, hey, the space between head and the equals signs is saying, this is what the change of the branch you have open is. And we call whatever the branch you have open currently to be your head. So if I were to have, commit number 5 open, my head would be here. But traditionally, a lot of people get confused. So usually you have the latest version of the code open, right? So that's what a lot of people consider head to be. But if you were to check out commit 5, that's where your head would be. And your head is considered to be in a detached state, and we'll go into a little bit further if you're pointing at something that is not the latest version of the code. Okay, yeah. So whenever you're trying to resolve these conflicts, what you have to do is you go through every single one of the files that has a conflict, and you pick one of the 2 versions, right? So suppose that when we started VSAT, we used to do issues on GitLab, but now we have a project management software. So now if there's an issue, you should open it up there. So we want to pick this version now. So all you do is you delete all the space between head, open an issue, and the equal sign, and then you'll just remove the branch A. And essentially, whatever you leave the code to be will be what will be added to the Git version, then to the Git commit, which will become its own new version of the code and what you'll push. So sometimes you have to pick one of the 2 versions, and then in really bad cases you have to edit them, and just to get it to work. Yeah. So you pick one of the 2, or add an alternate version. You remove all these labels, and after you're done, you add it, and then you make a commit once you're done, and you push it, and that should merge the branches together. Okay. Any questions on what I just went through? I feel like it was a lot, and it was very abstract. So we'll go into it a bit more in the simple demo and advanced demo. Okay. Cool. Okay. So first, we're going to be going into the Git setup. And the first thing that I want to go into is I just want to say that whenever you access remote repositories, there's 2 ways you can do it. One of them is, whenever you log into a website, you provide your username and password. Well, you can do the same thing for Git. You identify yourself, so you're authorized to push changes and get changes from the remote repository. Another thing you can do is use SSH keys, which is just a set of basically encryption keys that you can use to authenticate yourself. And essentially, just the rough gist of it is you have two pairs of keys. You have one that is a private key and a public key. The private key is private because you don't want to share it with anyone. And the public key is public because you want everyone to have it. So if I have, for example, Noah's public key, whenever he sends me a message that he signed with his private key, and signing just means applying his cipher to it, I can then use his public key and then read the plain text. So he's, he will grab his private key and plain text, change it to ciphertext. Anyone can try to intercept this, but they won't really be able to understand it. But I'll be able to check it and be able to read it. So if he's, if locally he's saying, hey, I want to access a remote repository, I am Noah, he'll send it to ciphertext. It'll get to the server will sign it, and it'll say, oh, because I was able to open it and only Noah has the private key, then I know that it's him. And it can then check the plain text and say, oh, okay, this is what his account is. Oh, yeah, just a little note on this. I flipped these around. So .pub means public, and when it doesn't have the .pub, it's the private one. So I will change the slides, but yeah, please don't confuse .pub and .rsa. Although they're symmetrical, so it doesn't matter. You can pick whichever one, but you just can't share the other, and you have to be consistent about it. Okay, so here's a little thing that we can do right now. So I guess a lot of you have already done this, but what we're going to do is we're going to add, generate an SSH key and add it to, we're going to add it to the repository, just so you can clone without having to log in. Yeah, so for this one, anyone who hasn't been able to, add your keys to the repository, you should do it now. And just so you know, if you've done it, you should run this command right here, and it should be able to identify you. If it's not able to identify you, this is what you should do. And this is just very useful for you to identify yourself. So yeah, I think we can spend a little bit of time on this.
Yeah, so maybe the way we can do this is if you've already set up SSH keys in GitLab, just send a message in the chat and we'll know you're good. If you haven't, then follow the steps here and send us a message as soon as you have set it up. That sound good to everyone? And for anyone on Windows, if you're wondering where to run that SSH keygen command, you can do it in git bash.
Should I walk people through a new one, or if anyone is stuck, just say I'm stuck and we can go to a breakout room and help you out. Comment is just, you can add a description to your key. So if you open it up, you'll be able to know who it's from. This is optional. So you can just do SSH keygen up to here, and they'll generate it for you.
If you're juggling multiple keys, that's when you'd want to use the comment. So like you might have one key for GitLab and one key for GitHub, and you can make that the comment. You can also use the same key for lots of different services. So.
How's everyone doing? I might as well pause the recording. Okay, cool. Now that everybody is done, you should be able to clone any repository from our Aliyah site. This is assuming that you provided your GitLab to Noah, or like you put it in the form and we added you to it. Is there anyone who cannot clone, does not have access to the GitLab repository? So, if you want to check if it's working, something you can do is you can try to clone code. So what you do is, if you can view this page, you're pretty much set. So if you click on it and you get here, it means you're practically able to clone it unless something went terribly wrong. If you're not able to view it, it means that your account hasn't been added to organization and you should make a comment now. But effectively, once you do this, you'll be able to use clone with SSH, copy this, and you'll be able to clone without having to put your username and password, and it's a lot more secure. But if we didn't do this and you didn't have your SSH keys up, you would have to clone with HTTPS, where you would have to provide authentication. Okay. Any issues with this? Okay. If you never filled the form out, you should paste your GitLab ID, which is this one. And we'll try to get that resolved because you'll need access to this for the workshops. Okay, awesome. Okay. All right, so now have your terminal open. We're going to walk through this. So whenever you do Git, as part of the commit is you'll identify whoever made the commit. So then that way, whenever we're looking at the history of a repository, or just the log of all the different changes, we're able to tell exactly what's going on, who did what, and basically we know who to talk to find out what was up with a commit. So whenever we look at the history, we're able to see, oh, this was from Ethan, this was from me, this was from me, this was from, sometimes you'll just see this, or it's just an E. And on this side, I know exactly who this is, because I've spoken to them, but if we look at this, we're not able to identify them. So what you have to do is you have to add your details to the git config. Sometimes it's done for you automatically, but oftentimes no. So what you should do is run git config list, and this is going to list all your entire git config, and at the bottom it's going to say your username and your user email. If these two fields are empty, you should run git config global user.name. You add your name, and this will be whatever appears in the history, and the email to contact. Okay. If anyone is still working on this, raise your hand up. If not, I'll move on. Also, if it's not clear, please ask me. I don't know why my email keeps popping up.
Ted, I see your hands up. Did you have a question?
Oh, I told them to raise their hand if they're adding
Oh.
their config details. Yeah.
Sorry, totally missed that.
Okay. What I'm going to do, the commands on chat. Just so there's a reference. Okay. Oh, okay.
I can hop into a breakout room with you, Ashwin, and we can see what's going on with the SSH key. Just give me 1 second.
All right. How are we doing, Ted? Okay. I am going to why do you need to re-enter git at gitlab.com? Yeah, you just enter this into the terminal. So all you have to do is to git config, say we want to change my email. And then you should see the list. Right over here. Okay. Okay, I think I have to move on. This is going to slow down everything else. We still have a little to cover, but yeah. Okay, so I'm going to go into the simple demo, and we're just going to do a couple things. I don't want you to fall. I just want you to pay attention. You don't necessarily have to walk through this. Okay. Cool. Okay. Let me know if my terminal is not visible. But the first thing we're going to do is we're going to clone a repository. So, whenever you're cloning, you're going to be doing it in whatever path you have open in your terminal. I don't want to have it in my .ssh folder, so I'm going to move it to a more appropriate place. So now that I have a repository, I have a folder open where I want to have it, I'm going to run git clone. I'm cloning the Git tutorial, and because my SSH key is there, I don't have to identify myself. I'm going to cd into it. And as you can see right here, it's a pretty much empty repository. The only thing it has is a README, and the README only says Git tutorial. So, let's make a few changes. I am going to make a new file. So I'm going to say example. This is an example. And I added a new file. So I can see it right over here. And here's the first command that is going to be super useful. It's git status. And this just tells you everything that you're doing. So basically, it'll tell you what branch you're in. A lot of terminals will tell you what branch you have open. Yeah, and then it'll also tell you, hey, you have these files that you didn't tell me to, ignore or add. So, so most of the time when you see this and say, hey, I want to check in example.txt, I just added, and it'll say, hey, you added a new file. And it tells you changes to be committed. This is basically telling you you've added it to Git, but it's not in an official commit yet. So do is add it to commit and say, hey, adding example.txt. I just made a commit. And this is saying, hey, I'm ahead of origin main by one commit. This is basically saying, I grabbed the main branch and I added one commit on top of it. And it's telling me, hey, you're ahead of it. Git push to publish your local commits. And this is essentially just, I'm going to grab my local repository changes and put them into the remote one. Push origin. Main. So what this command is doing is you're saying you're pushing source and main. So origin is basically whatever branch you have open. And then main is whatever you're pushing to. A lot of times what I like to do is just do git push origin head, because head is just a label for whatever branch you have open in your repository. Oh, you have open currently. Okay. So if we were to open the tutorial, just have this open, you'll see that now my example.txt is up, and you'll be able to see, hey, Julian published adding example.txt for the tutorial. So let's do a couple more complex things. So let's make a new branch. Say, someone told me I needed to make the README a bit more descriptive. So I'm going to make a new branch. What I'm doing is I'm checking out a new branch. And if I add the /b flag, it means create a new branch. And I'm going to call it update README. So now you'll see that instead of being in main, I'm in update README. And I'm going to make a little change to the README. So I'm going to make a little change. And as before, it'll say, hey, you modified this file. And you know what? I also don't feel like the example.txt is a very useful file. So something I could do is I could either remove it. And this will say, hey, you deleted it. Or another thing you could do is, and then you'll delete the file from Git. Usually you'll do git remove when you added it, but you didn't commit it. So for example, if I do, touch test.txt, you'll just say, hey, you modified these, and these are unchecked files. But if I were to add it, you'll see I added a new file called text.txt, and I modified these. But if I were to remove it, the file is still there, and it's still added to my local commit. So, sometimes this will happen, and you could, it's basically, I don't want this history to be pushed to Git. So what you can do is git remove. And, it's like it never happened. But yeah, what I've done is I made a change to the README, and I made a change to example.txt. So I'm going to make a commit. Cleaned up repo. And updated. So first I need to add. So whenever you add something, you're basically saying, hey, grab these changes and I'm going to add them to be tracked. So what it's essentially doing is I'm accepting these changes into Git, and that'll appear in green. So then whatever's in green is what gets added to the commit. And now I'm going to push my changes. So in this case, I can do origin head. And this is going to push everything to update readme, or I could have also written git push origin update readme. And sometimes you're like, oh, did I push it to the right one? You can just see, the branch, and you'll be able to read what's going on. But yeah, let's look at it right here. So we should be able to click on this if my terminal is being nice. And what this is, whenever you click on it, it'll open up on a new merge request. But let's not do that right now. So we're looking at our repository, and now we can see, hey, we just made a new branch. So we can click on it, and now it's just the README and the change in the tutorial. And something that we can do is we can create a merge request. A merge request is just a way to publicly merge two things where other people can review it. So usually what we want to do is create a merge request and add a little description. So if we're checking code into the satellite, here's where we'd say, oh, I tested it under these scenarios. I'm going to assign it, to these people to check it, or I'm going to add this specific reviewer to it. And then you can add more information to it. So I'm going to create a merge request, and you'll see that now, merge requests will have, whatever the count of merge requests was before, it'll add it by one. And you'll be able to view the commits associated with a merge request, and you'll be able to see the changes. Okay, yeah. So something that I'm going to show you now is, so a lot of times you'll have a lot of merge requests open. So now we need to work on something else. So I'm going to I'm going to go back to main. And I just switched. And whenever you check out to main, it means that whatever is on main is what's going to be open. So as you can see, example.txt came back and readme.md came back. So let's add a little change to main. And let's add something else. Let's say, this is a new header. Okay, so I just made a change on the main, but then there's also a change in my, update README branch. So if I go back into main, you'll see, hey, there's a new header here. So when I go back into my merge request and I attempt to merge, it'll say, hey, you have a merge conflict because we changed the same file. So we can, do a little local merge. So, most of the time, if you can resolve the conflicts or you can merge locally. If you just click resolve conflicts, when it's very simple, you'll be able to use a UI, but usually we do it. Nope. Usually we want to do it in the command line. So this is what you could do. Yeah, so basically you'll fetch the changes. You'll do a quick little checkout. You review it, and then you will merge it. So let's do that. I don't have to fetch anything because it's local now, but if I go into Git, yeah, I guess I could do a merge, or I could show the cherry pick now. No, I'm just going to do a merge. So update README, I'm going to, just in case, Git. Oh, okay. So this is just complaining that I tried to fetch a branch, but not a repository. So now I'm going to be fetching origin. Origin is just whatever we label the repository to be. So whatever you fetch, you're grabbing all the changes that are upstream and you're putting them downstream. And I'm going to say, hey, git merge, main with update. It's telling me that they're commits. So whenever you run git status, it's saying, hey, you both try to modify readme to RMD. And you'll see what I showed you. Yeah, fetch is like a pull in a lot of cases, except you're just making it aware of all the changes. Whenever you're fetching, when you're pulling a specific branch, you're only doing the branch unless you have a specific command. But if you do fetch, it'll be everything. Yeah. Oh, no, I said. Oh, okay. So when you're fetching, it doesn't affect whatever the. Oh, okay. So just to clarify, a pull is a fetch plus a merge. Well, a fetch is just you're saying, hey, there's changes in. So Montekib just asked, when you're fetching something, is that the active branch now? Not necessarily. So all you're fetching is the remote repository. So whatever is in the web, gitlab.com, I'm just grabbing those changes. If I were to pull things, I would grab those changes and then merge them into my local branch. Okay. Yeah, so I'm going to resolve this real quickly. So, I went through this and this is how I want it to look like. So most of the time when you're doing a merge, in reality, all you're doing is you're looking at the changes from both branches and you're editing it. So it ends up being whatever you want it to be. So you're adding it. There's still a conflict because you haven't added it. So if you're not careful, you could end up having the greater than head and all those labels. I made the modification. I just need to commit it to say, hey, I fixed it, so fixed merge. So whenever you do this, I just pushed the merge resolution. So if I were to refresh this, now I'm able to do it. And you'll see that there's a new commit that is fixing the merge conflict, and I should just be able to merge. And just to show you that it actually changed things, if we go into main right now, so check out main. You'll see, it's git tutorial, this is a new header. It hasn't been updated yet. So you can do a git pull or a git fetch. So if I do a git fetch, origin, it looks exactly the same. It's just saying, hey, there were some changes over here in origin.main. But now, I want to, merge them into the local. So git pull origin main. So I'm pulling from here, from this repository and from this branch. I just did it and it's saying, hey, I added a few changes on the README and I got rid of example.txt. And we'll see the changes reflected there. Okay. Was this clear? Anything you like me to expand on? Okay. So just to go through some definitions, adding is just you're adding the file to the commit. Removing it, so git remove is you're removing the file from the commit. A merge request is the process for others to review proposed changes, because a merge is just joining two things. And yes, a pull is just fetch plus merge locally. All right. I kind of want, we're running kind of out of time. So for the advanced demo, I'm just going to show you some other things you can do real quickly. So as I showed you head, just tells Git what version of the commit you have open. So whatever I'm looking at, it's the commit I have. So for example, let's look at the Git log. I can see all the different, so we've made a total of 3 commits to this branch. We've done the first one, the second one, and then this more recent one that we did this morning. Actually, we've done a few more. So, I want to look at this specific commit. I'm going to do git checkout. I'm having a great time. Okay. So I just checked out to the new branch, and as you can see, I'm in detached head state, which means that what I have a commit open, but this is what not the latest changes are. And if I make any changes here, I'll be making a new branch. So that's just that. So if you do switch C, you can create a new branch name where you're going to go back into that commit and create a new branch at that commit. Or if you just do switch C, you'll just revert it and go back to the local. Cherry pick is when you grab one specific commit and you add it to a branch. So usually this is for like a hot fix where it's like, oh, the SPI drivers are broken. Quickly cherry pick that fix everywhere. Tag is, you're just adding a label to a specific commit so you can reference it. So for example, if you're like, oh, this is the version 1. So you will add the version 1 to a commit and you'll be able to reference it that way. Working tree is whatever working directory you have open, and event is a way for you to change the contents of a specific commit. I added a link to a very useful cheat sheet that explains all the commands that I did and more quite well, and it has some diagrams to explain things. Okay, any questions? Okay.